Hello everyone, and today in this video I want to talk about the Pyro Source. In the last video I have covered the Pyro Solver. Pyro Solver was that how those attributes, volumetric attributes value change over time, but today I want to talk about how we can source our values by Pyro Solver using this SOP node Pyro Solver, and how it is different than like giving manually the attributes, the volumetric attributes manually. But here I will do this by the Pyro source. So let's jump into the video. I've created a setup for you so you can have the values, because these things like fire and everything takes time to get to the desired result, but you can play with these values. But what's the thing is, like, I cannot waste the time, so I have some predefined like values. I will use it, but here let's cover the basics first. I will introduce a new node today, which is a VDB from particles. This is not new node, but in here this is a new node. So first let's create a geometry. I want a sphere. I have this sphere and the background color is dark. I can say dark gray, and turn on the grid. I have real-time playback is on and I have these frames. So let's say 120 frames. Okay. I have this sphere. So this sphere is a geometry. I want this to be a primitive geometry. Primitive geometry, I've covered the primitive geometry in the clouds video. Here we have only a single point, and this point can be converted into VDB by VDB from particles. So I have this VDB from particles, and you are seeing the sign distance field. Right now we have the distance VDB surface. I don't want this to be surface, I want this to be density, and voxel size, we have everything. So let me just create a Pyro source real quick. This is our Pyro source, and you need to like connect this to some geometry. So let's say sphere. So we have something like this. You see some like similarity here. We created a sphere, and with that sphere we created like VDB from particles, because this sphere is a mathematically perfect sphere, so it has only one point and a radius. I've covered this, and this sphere is made up of polygons. Pyro Solver, what it is doing? First thing, it is like converting it into points. What when I mean by converting, like it is making some points, it is creating some points onto this sphere, or it can create some points inside the sphere, like the voxels. You see, these points are filled in this sphere. So now it is something like voxel, but not like voxel. I'm just giving you a reference. Like we have 3D voxels, like the cubes inside the geometry. It is something like this, but these are just points scattered inside this volume, inside this geometry. I have this Pyro source, and it is first creating some points. And I have to convert this VDB from particles, because when I toggle this on, you see something like this. Let's do the same. VDB from density. You are seeing something like this. When I decrease the voxel size, you see something like this. When I give this, and when I decrease the point radius scale, you see what is happening here, right? So this Pyro source creating these points, and these points have attributes. These points have attributes. Right now, these points only have the p-scale attribute, but when you open its parameters, you see we have first the initialize parameter here, initialize option here, and we have the mode. You can surface scatter, you can volume scatter. keep inputs. We don't need to worry about this right now. Just remember this: surface and volume, surface onto the surface and volume inside also. Let's say volume. You can create two things Pyro Source is doing here. It is creating those points and it is giving some attributes to those points. And for example, I have this attribute parameter here. You click on this, you create a parameter here. You are creating a parameter here, and this parameter name you can select from this, or you can type this, let's say density, or you can select from this. It is the same. So we have density right now, right? So this density parameter, we have this density parameter over here. You can increase or decrease the value by this scale. And here I have this initialize button also, but here I want to create another attribute, which is temperature. Same, you can increase or decrease the value. I want this to be default for now. Okay, and let's delete this. Now let's talk about initialize. This initialize, you can create some attributes based on these key. So we have source smoke. Smoke means temperature. In the last video we talked about this. Smoke means temperature. Very important, density, right? And we have the burn if we want to create some fire, right? Okay, let's say I want this source burn. We would have burn and temperature, because burn is only fire. We have burn and we have temperature. Temperature would create the buoyancy. Temperature will create the buoyancy force. And right now we initialize these to burn. We can initialize this to smoke, so it will generate a density attribute also. So now we have three attributes, 1, 2 and 3 onto these points, right? These points contain these these points have these three attributes. Now we are creating some VDBs from these points, and you see it is on surface. Let's say density. We are creating density VDB, and we can have the voxel size. You can increase the point radius. This point radius scale is the final value. If these points have p scale value, these point radius scale is like multiplying with the p scale value to give the final value. So if I'm saying 0.5, that means this 0.5 will multiply with the p scale value, but here these points have the p scale value, you see 0.2. So the final value would be this where it is, this 0.5 into the 0.2, and you get the final scale of these of the VDB. Right now we have something like this. This is our, let's say this is our VDB, right? This is our density volume. And what you can do, in the last video I talked about Pyro Solver, how these values would evolve over time, right? Over frame, like by each frame. So this Pyro Solver, in the last video I talked about the sourcing, right? What this VDB is giving us, it is giving us a density. We can create more like temperature and other things, but here the real important thing is we don't need this VDB from particles. We don't need this. So what this Pyro Source is doing, when we manually create a point, then VDB, then each density, each volumetric attribute like density, temperature, burn, we don't need to do that anymore. So Houdini pre-modified it in a way so we can have like easiness in creating those. We can automate the steps. How? You know that these points have these attributes right now: temperature, burn, density. How we can create the volume with these attributes like already made for us? We have this volume rasterize attribute node. When you give this, you see nothing, because we have to tell it which volume attribute it must, like it needs to create, which volume attribute should this node create into the VDB. I want the density. Now we are seeing the density. I want the temperature and I want the burn. We have something like this. You can increase or decrease the particle scale, and the particle scale here, like this particle has a radius of influence, this particle has a radius of influence. So these particles at their radius of influence, we are creating a volume. Here when you increase or decrease the particle scale, what is happening here? Particle scale is the radius of influence here, and you see the voxel size. Now we have these three attributes, these three fields on this on these particles, on this VDB. Sorry. So we are converting these volumetric attributes into the VDB with each field. So right now we have this. You can increase or decrease the voxel size. Voxel size cannot be like too high, because when you say you have these two particles, and when you say like I want this much voxel size, so the point scale radius should be inside the voxel size, so it can have that particular field inside that voxel. We have this, and we have the Pyro Source. We also have the burn now, so we would see something like this. When you play this, you will see this going up very fast. Why it is going up very fast? Because we have the burn, and burn creates this glow, this fire-like look, and we have the temperature. Temperature it was creating. Where is the shape here? It is creating the buoyancy. Buoyancy push is the smoke upwards. In the last video, I have talked about buoyancy in detail. I have this volume rasterize attribute. I want to talk about this for now. We have the voxel size, we have the particle scale. Let's decrease voxel sizes, I guess enough. Let's say 0.4 for now, and particle scale. You can decrease the particle scale. You can increase it, you can decrease it. This is just for a reference. We will create our main thing here. I have this Pyro Source, I have this sphere, right? So you know now what this Pyro Source is doing. It is creating some points, then it is converting, it is giving those points some attributes. Then volume rasterize attribute is converting those attributes into their particular volume fields, right? So let's create our first simulation here. Let's create a file node here and toggle this on. I have this file here. I want to import a geometry here. I will give you the link. I have downloaded it from somewhere. I guess I don't remember right now, so I will give you the link. You can download it and follow along. I have this file. I will just import this. I have let's say where it is, assets, and I have the campfire fpx. Yes, this is too much right now. Match size. I'll connect this, and I will give the scale to fit. Target size I want 5, 5 and 5. We will see not 5f, I want 5. So this is and minimum. I have talked about the match size in the, I guess, very first or the second video of this series. So if you don't know about this, then go and watch it or follow the steps. I have this fire right now. We don't need to assign the textures right now. I don't want to see it in the viewport. We will assign the textures when we will render this. No need to do it right now. Let's create our Pyro Source. I have this Pyro Source. And here it is doing the same. It is creating these particles onto our object. I want to say volume scatter and source burn. I only want burn and temperature. Burn to see the fire and temperature to have the buoyancy. We will see nothing because nothing is happening here. We just have our points, and here we have the temperature and burn attribute, volume attribute here. I want to give this volume rasterize attribute. Connect this and attributes burn and temperature. You will see something like this. We have the voxel size, and here we have the point separation. So you can decrease the point separation. Lower the distance, closer they are, and the higher the density of these points onto the surface. So we will have more detailed smoke, more let's say high res smoke, high res simulation here. We have the volume scatter, and when you play this you will see nothing because we need to give this Pyro Solver to like have and we need to have the Pyro Solver to give this how those values change over time. Pyro Solver, and connect this, you'll see something like this. Now when you play this, we are seeing the perfect result here. What is happening? We have our sources. We don't have density to, so turn this off. We don't have velocity right now. Velocity is here. Velocity is here, but velocity is not coming from this. Velocity is being generated by this buoyancy. Just forget about it. I've covered the velocity in the last video, so I won't, but just if you like want to have the understanding, velocity is not, we are not importing the velocity from the Pyro source, but here velocity is being generated and velocity is pushing those values onto their like say upward, onto these voxels that are on top of these, like let's say you have this voxel roller, right, and there are voxel field. This is a grid of voxels, so like voxels that are on top of each other, so we are pushing this value. So this value is being pushed by velocity, and velocity is being like here is created by this temperature. Temperature is creating buoyancy force, and force is being applied to those voxel. Let's say it's just simulation, so these are just values. So these force is applying onto those voxels, and these voxels now have the velocity. I mean, velocity is like an imaginary thing here. So velocity is just data value. So this is like pushing those values like on top of each other of the voxels. We have the Pyro Solver. When I play this, you will see something like this, and it is the results we are getting. And we have the buoyancy that is pushing this fire higher. We can decrease or increase the buoyancy, but here you see we have the R volume, our Pyro source, and you see we have these points which are being created into VDBs. I want to give this noise so we can have something like something some change in our source, so we can have the real life effect. And for that we can give this attribute noise. You will understand this when I connect this. We are saying something like this, and I want this to be float and temperature first. You can delete this. So I have this temperature and I toggle this on. Nothing is happening because we are in the attribute noise value. And you are saying our temperature is here red. That means temperature is spread on like every point. So we have temperature attribute on every point. But what if I give this a noise and let's say zero centered, and let's say add. So you are adding the noise value on top of the values that are present in these points, the attribute values that are present. So we are adding the zero centered value here. Zero centered means that it's like changing the value range. If the value is coming from like 0 to 1, right, the value is coming from 0 to 1. Zero center is doing pushing this value around 0, like -5 to +1, around 0. 0 would be the middle. We have the amplitude. You can increase or decrease. So when I increase the amplitude, you see these values are getting like red means high temperature values, this green and this blue and purple. When you see this purplish, now we are decreasing temperature values onto these in these areas. So we have like high temperature values, and these are low temperature values, and orange and greenish means in between, like values in between these. So we can increase or decrease. We can animate this, like let's say pulse duration 1. We are animating this, and I have talked about pulse duration in the last video, I guess. So we are animating a noise on top of these values, and we are visualizing our temperature here. So when I go into the Pyro Source, you remember what this temperature is doing here? Temperature is creating the buoyancy force. So where the temperature is high, the force is high. That means the more like fire will move in that direction. It will move more in that direction strongly. When I play this, you will see something like this. So now we have this noise, and this will create the indifference in the buoyancies by each frame, so we can have the more natural tap look. We have a temperature, and we can give this same attribute noise to the burn also. Float and give this burn. We don't want CD, so when you visualize this, you will see something like this. Everything is burning here, but just give this noise, let's say zero centered, same. You can give this noise, so you will see something like this. When you toggle this on, you see these parts have more burn value. That means we will see these will burn more than these. So it is just like the visualization. We are visualizing this value, this burn value, into something like the fire like look. This is our software doing. These all just values, and we are visualizing these values as fire here. This glowish shader, it is for the viewport visualization, and we will give this shader when we render this. So we will see something like this. You can say animate, post process, minimum and maximum. So the values that are coming from this burn attribute noise will be from 0 to 1. So we cannot have like values that is going in minus, right? Okay. We are seeing something like this. So when we have this our Pyro source, you can decrease the particle separation here by, like, you can copy this parameter and Pyro source, give this relative reference, and that's it, I guess. Yes, we have this. So when we increase or decrease the voxel size from here, this will also change. You can like set it here also, but yeah, let's set it here, copy paste relative reference. So when you uh, decrease the voxel size of this setup will change. I have talked about this in the last video. And we have these fields. We have flame lifespan, something like, you see this flame is going really high. You can decrease the lifespan so we can see. So the flame ends like really low. See, something like this. I want this to be 1, and you can have the look. And I want to like tell you something here. This look is for viewport only. This look is for viewport only. When we give this shader, when we give this a fire shader, we will create a new look. But to make this like fire like, so we have this. What is this color ramp? This wait, let me just, you see, this is the inside. Black means like visualization is low, like we cannot see it. Black means dark, nothing. And here color, we have this color. So when you move this black, it is like a radiant, it is like a gradient, sorry. And just reverse this, so you will see its effect. When you move this in between, you see the blackness is going from the outside inward. So these voxel, these glow effect is getting like lower. You see this? When you play this, you'll see something like this. So we can see this effect. You can increase or decrease the intensity scale, but I want to like tell you again, this is for viewport visualization. It does not matter to the render, because render will create our shader. We have the smoke, we don't need smoke here. And fields, we have sourcing is good. Shape, I want turbulence, give this 2. We have disturbance, you can add disturbance too, and you will see something like this. Now we have these turbulent noise, and you see this is going way far in the, like it is going too up, it is high like rising very high. So what we can do, I don't want to decrease the buoyancy here, because when you decrease the buoyancy, we will have our smoke going really slow, because the less forces, the less velocity it would get. So I can decrease our source scale here. You have this pull. So pull is something like, you are getting a value and it works on each frame. So let me give you an example. The value right now is 1, right? And you are sourcing this 1 value on each at every frame. When I'm saying pull, that means pull this value. Pull means here going something like this, like increasing per frame. First frame 0.1, second frame 0.3, then 0.5, 0.7, 0.8. You are pulling it from 0 to the 1. We have this pull, copy, it is copy, just copies the value. I don't use it. We have add, subtract, multiply. We have add, minimum, maximum, pull, average. For here you can say add. So we are adding the value again and again at every frame. I have source scale. You can give this 0.1. When we have like not 0.1, so less temperature, less buoyancy, but we are not decreasing the buoyancy, we are decreasing the source. When you play this, you will see something like this, and you can decrease the source of the burn here. That means you will see something like this. And we can have in the look tab, you can decrease the intensity scale to something like 15. Let's say what is happening. Yes, you will see something like this. So I have like made some changes before. In these, you can increase or decrease the voxel size, you can increase or decrease the sourcing, you have these fields: flame lifespan, you can say 0.5. You will see something like this. We have this fire right now, and you see how the noise is working. It is creating these patterns, right? And I have created some values, like I have worked this, I was playing with these values, and I have got this and I have cached it out. So you will see something like this, right? And this is just for viewport, but these patterns uh, I have gave this by these values, so you can see these values. You can put these values. I have the attribute noise, and here I have this noise which is set to at positive, and amplitude is 4.17, and is working on temperature. Animation is on, and minimum maximum. Here we have burn, and I'm only burning this. These are not burning right now. Burning is set to B, and it's add positive, and no, it is not burning. Yes, burning is operation set to set. Set means like overlapping these values, the noise values. It is overlapping with the initial values, which is zero. Centers mean the values would be from minus, let's say from the center would be zero, like center will be zero. We are using the animation, same. We have volume, rasterize, nothing. We are rasterizing temperature and burn. We have the Pyro Source, and you can like screenshot this. You can put this value here, the voxel size. This voxel size is for the render, not for this simulation, because this is really small. That means high resolution, so it will take more and time. And we have sourcing. We are, you see, source scale, and it is set to add 0.1. And fields, I have dissipation, I have diffusion. Dissipation, I didn't make any change. Diffusion, I didn't make any change. Buoyancy, I set to 2, and set to 2 because I want more force, like this smoke is like pushing higher, like with more force, so we can have the real fire-like effect. Turbulence set to 2, so we can have these uneven like velocity changes into the fire of the fire. We have look. This is just for viewport, and this is just finish. I have cached it to like for uh, to make this easy for my like Houdini. So we are storing the data not into the RAM directly. We are storing this into the SSD. I will cover this caching in next video, and in the next video I will like uh, give this a shader, and we will render this fire. I've showed you the values, put these values, and have this effect, this fire-like look, and in the next video we will render this. But today's videos a reason to talk about this Pyro Solver, because we have covered the Pyro Solver. We know how these values can change, but here I want you to understand how these things work really, like how these things really work. So these two videos, Pyro Solver and Pyro Source, are really important because it is a base for like everything we will create next. So this is it for this video, and I will see you in the next one. Until then, take care.